Okay, good morning students. As you know, my name is Subodh Pandey and you are floating with me in the world of physics. In this chapter, as you know, the chapter name is your fluid mechanics. So, in that particular chapter, we have a new topic for you and the topic is manometer. So, what is manometer? In the previous lecture, we have discussed about the barometer. As you know, that barometer is basically invented by the Torricelli, and here in this case means we have a new device and the device name is manometer. So what is manometer and how it works, what is its purpose, we will discuss in this lecture only. Okay, so let's get started. Firstly, you can see here that it is clearly written we have a manometer, and the manometer is basically a simple device to measure the pressure in a closed vessel containing a gas. Means we have an instrument, okay, and that particular instrument named as manometer, and it is used for measuring the pressure in a closed vessel, and in that particular vessel there must be a gas inside it. Okay, so as you can see here that this be your vessel, and in this vessel let be these are the molecules of the air. Okay, so these are the molecules which I am trying to show you, and these molecules are up to the end A as shown here. Okay, so maybe the A is the knob by which you can turn it on or turn it off. Okay, so basically we have to calculate here the pressure of the gas which is contained in that particular vessel. A is that knob through which the gas can passed out. Okay, so now we have a U tube, or we can say that a tube which is in shape of U. So you can see that this be your U shaped tube. Okay, this will start from A, then passing from B, then C. So this is a U shaped tube. Okay, and in that particular tube there is a fluid here. As you can see, a fluid is there which is shown in black color. Okay, now the tube has two ends, we know very well. Then one end of the tube is open, so this one is your open end, you can simply say. Okay, and the other end is connected to the vessel. So other end is connected to the that knob which is represented by A. So one end is connected with the knob and other is your open end. So this is the system, this is the configuration of the manometer. So I hope that up to here it is very clear to all of you. Now what, because we have to calculate the pressure of the gas, and gas passed out from the knob A. Okay, it means in short we can say that we have to calculate the pressure at point A, because whatever the pressure is at point A, that is the pressure which is inside the gas of the vessel. Okay, now here we have some basic principle. The principle says that if we talk about the same level in a fluid, let's suppose we have 2 points A and B which are on the same level. Okay, then we can simply write down that the pressure at point A must be the pressure at point B. So here you can easily see that we have what we have this one is your level, and point A and point B both are at the same level. So this concept is applicable here. It means if we want to find out the pressure at point A, then we have to calculate the pressure at point B, because whatever pressure is at point B, that must be equal to the pressure at point A. So I hope that up to here each and everything is clear. Now what is the pressure at point B? So what is the pressure at point B? So that is the concept of vertical column. So I have told you, I have explained you that if it is your vertical column like this way, this is your vertical column, let be, okay, and in this column you have fluid, okay. So if let be this is your fluid in that column like this way, okay. So you can easily understand that if this be your container, okay. So if we take 2 points here, let be that is your point X, that is your point B, then we can simply write down that the pressure at point B will be equal to the sum of atmospheric pressure, because the point X is just below the atmospheric pressure. So we have atmospheric pressure P naught and plus the pressure that is H rho G. If the length between these 2 points is H. So I hope that up to here each and everything is clear. So you can see in this diagram that the point C and the point B having a separation H. It means point B is H unit below to the point C. Okay, so by using the same concept we can write in case of manometer, we have point C, point B, and that will be we have here, you can see that point C is felt the atmospheric pressure. So we can write that the atmospheric pressure means the pressure at point C plus H rho G. Here rho is the density of the fluid, which is in the U tube. Okay, so I hope that up to here each and everything is clear now. So basically we have criteria that this be your U-shaped tube, this be your point C, here is point A, here is your point B, and the depth of point B from the point C is H, as is in your main diagram. So you can see here that is C, that is B, that is A. Okay, so this one will be, you can simply say that the pressure at point A, that is the pressure of the gas, okay, and that must be equal to pressure at point B, and the pressure at point B is basically the B is at certain depth, so it will be equal to P naught plus H rho G. So I hope and I believe that the basic concept of the manometer is clear now. So by using this concept you can easily calculate the pressure in any container filled with gas. Okay. Now we will discuss your next topic. Your next topic is Archimedes principle. That is quite a very interesting topic. Okay, so we have a few things to remind you here, that you can simply say when a body is partially or fully dipped in a fluid, the fluid exerts force on the body. So you can see that if we have a fluid here, so this be your fluid, okay, like this way you can see in the picture, and your body, okay, whatever body you have chosen, that is dipped inside the fluid. Okay, so because the fluid has a property of pressure, and we know that clearly that pressure is nothing but force per unit area. It means we can write that force is equal to pressure multiplied by area. So, and the nature of the force is always perpendicular to the surface of that particular area. So these things I have already told you. Okay, now what, as you can see here, these arrows represents the direction of the force. Okay, so each arrow is in the perpendicular direction. It means these forces are due to the pressure exerted by the fluid on that body which is inside the fluid. So there are several forces depending on the edges of the body. Okay, so this is the spherical shape here. It means each and every part of the body will felt some force due to the pressure of the fluid. Okay, because we know that the force is a vector quantity, it means we have some resultant here. Okay, so let's suppose that force be F, that force be F, that force be F, this one is F and this one is F. Means because the fluid is same. Okay, if the fluid is same, it means every molecule is homogeneous in nature. It means the pressure will be uniform, and if the pressure will be uniform at that time, we can simply say that the force will be equal in this situation. Okay, but if we consider that some vertical configuration is there, in this condition the forces will be different. Okay, so let be the upper forces. Firstly we will rough it and then I will show you that let be that the lower edge of that body is having some vertical depth. In that condition, the pressure at these lower points will be more with compared to the upper points. Okay, so basically if the force on the lower edge is greater, so let be that force will be F1, F1 and F1, and upper will be smaller, so be F2 and F2. So we have some resultant force which can be given by F vector, that will be sum of F1 vector and plus summation of F1 vector plus summation of F2 vector. Okay, so this force is basically the resultant force what we get due to the forces applicable on the body itself. And here itself means due to the fluid pressure. Okay, so that resultant force is basically called the force of buoyancy or buoyant force. Okay, so what we have learned up to here, we have learned that if we have a body which is dipped inside a fluid, okay, so let's draw a diagram like this way. Okay, and if the shape of the body is having vertical height, okay, in this situation let here is your fluid like water or whatever. Okay, so you can easily see that this part means just a minute, I will show you that this part has some vertical height. Okay, it means if we draw a layer here only, you can see that this be your one layer, this be your another layer. So the pressure at suppose this is layer A, this is layer B, it means the pressure at layer B will be greater than the pressure at layer A. And due to that pressure we have a force, it means force at layer B will be greater than force at layer A. It means we have force, we can say greater force at the layer B, whereas the force at layer A, that is the perpendicular to the surface, like this way or like this way. Okay, so these forces will be smaller for the surface A. So due to the imbalanced force, we can simply say we have a resultant force. Okay, so resultant force will be nothing but given by FB minus FA, and because FB is greater here, it means the resultant force will be in the direction of FB, and the direction of FB is upward. It means a resultant force will be acted in the direction which is upward. It means the fluid tries to just jump to the body. Okay, and that force is nothing but your buoyant force. So I hope that this basic thing is clear to all of you. Now what we have to do, we have to just go through the statement of the Archimedes. What Archimedes explains to us. Archimedes states that when a body is partially or fully dipped in a fluid at rest, the fluid exerts an upward force. So upward force, that is your buoyant force, okay, of buoyancy equal to the weight of the displaced fluid. So this word is very unique. Displaced fluid. What is the sense of displaced fluid? So for that I will draw a diagram to show this thing to you. Let's suppose this is your container, okay, and this is, you can say, a tube which is coming out from the vessel. This is the knob, maybe, okay. This is the rim of the that tube which is coming out from the vessel, okay, and the fluid is up to the rim of the vessel like this way. So you can better understand what I am trying to explain to you. You know very well that if more fluid I will throw in it, I will just put it in, then what will happen? Whatever fluid will comes above this rim, that fluid will come and collect in that container. It means some more amount of fluid, if is there, then it will directly comes out and collected on the another beaker. So this thing is clear. It means finally we can say that the maximum height which we can take in this container will be h only, means up to the rim of the beaker, which is connected with this pipe which is coming out from that container, okay. Now what? We are not in this situation that we can put more fluid in it, okay, because we can say that the fluid is up to the rim of the container. So this is the first condition. Now what? Now because we can't add more fluid, because if we add more fluid then it will come and collect in the another container. So we just stop to put more fluid in that container, and now we will start our experiment. We will take a body, and just that body is just dipped in that fluid like this way. It may be partially dipped, it may be fully dipped, okay, there is no problem. So we have just dipped it in that fluid. Then what will happen? The same condition, the same situation, you will see that the fluid will comes out and collected on another beaker like this way, okay. Now what? As I have told you that the body is at rest, okay. So this body is in rest position. It means simply we can say that the weight of the body, let be the weight will be mg, as you know, that will be in the downward direction, and due to the we can say the pressure of the fluid, which is the result as the buoyant force and acted in the upward direction. So that will be your FB, buoyant force, and in this condition the buoyant force will be equal to mg. So this thing is clear to all of you. Now what about this container, or what about the fluid which is in this container? Now if we take a balance and put our container on that balance with the same fluid in it. Okay, so this is your container, and when we calculate the weight of this fluid, then we will find that it is equal to the mg. What does it mean? It means the buoyant force that will equal to the weight of the body, and this will be equal to the weight of the displaced fluid. So this is the your we can say the Archimedes principle. So I hope that this principle is now clear. It means if we dipped partially or fully any body in any fluid, then it will displace some fluid, and whatever amount of the fluid is displaced, and whatever the weight of that displaced fluid, that must be equal to buoyant force. And if the body is completely dipped, in that case the buoyant force equal to the weight of the body. Okay, so we have a situation that FB, that is equal to W of the displaced fluid, that is 100% correct in each and every case, and FB equal to mg equal to W. This will be when we talk about that the body is completely immersed in the fluid. Okay, so we have a general formula that the buoyant force will be always equal to weight of the displaced fluid. Okay, so this is the universal truth. Buoyant force is always equal to the weight of the displaced fluid. And in the case when the body is completely dipped, then we can say that the buoyant force equal to the weight of the body itself. Okay, so this is your Archimedes principle. I hope that each and every part I have tried to explain to you, and just as I have told you that this is the journey of physics, and the physics is the study of nature. It means I hope that you can feel it in very gentle way. Okay, so we will discuss the question based on Archimedes principle. So here we have a question that it is given that 700 gram solid cube having an edge of length 10 centimeter floats in water. So firstly we will take a container. So let be this is your container, like this way. Okay, so this be your container, and in that container you have a cube. So this be your cube, let's suppose. Okay, like this be your cube. So I'm trying to draw a very neat and clean diagram for all of you. Okay, so now it is dipped in this water, because it is given that your fluid is water here. Okay, so this is your water, like this way. So diagram is very clear, I hope. Okay, and it is given that the edge means side, let be the edge be small a. Okay, so this be small a, this be small a, because we know that in the case of cube the all edges are same. So here we have that edge a, and that is your 10 centimeter. Okay, or we can write down 10 into 10 to power minus 2 meter. So this is the edge of the cube, whatever is floating in the water. And it is given that the mass of that cube, that will be small m, and that is 700 gram. So it is 700 grams, so it can be written as 700 grams, so 10 to power minus 3. Okay, so it will be in kg. So it can be written as 7 into 10 to power minus 1, that will be in kg, or 0.7 kg. So this will be your mass of that solid cube. Okay, so we have two things. First is the mass of the cube, and second one is the edge of the cube. So this is the first line of the question. Now, how much volume of the cube is outside the water? So firstly, we will calculate that what is the actual volume of that cube. So volume, that is actual volume. So actual volume, basically we know that the cube of the edge gives the volume. So here that is edge, that is 0.1. Okay, so this is 10 into 10 power minus 2, so it will be 10 to power minus 1. Okay, so 0.1 cube, and the actual volume, this is the actual volume, so it will be 0.001. okay, and because this is the volume, so unit will be in meter cube. So this is the actual volume. Now what the principle of Archimedes says? The principle of Archimedes says that when any body is dipped in the, we can say that in any fluid, then in that situation we have a certain water. In that case, the water is displaced here. So the volume of liquid that is displaced, so volume, and volume is nothing but we know that the density equal mass upon volume. Okay, so volume will be, because here density equal mass upon volume, so if we calculate the volume, then it will be equal to mass upon density. Okay, so if we have to calculate the volume, then we have to take the mass and the density, and mass is given to you, that is 0.7. density is also given to you, that is 1000. Okay, so that is 1000, this is the density. So volume will be 0.7 into 10 to power minus 3, and that will also be in meter cube. So this is the volume, we can say that which is the volume of the displaced water. And according to Archimedes, whatever volume of the displaced water, that must be the volume of the body or the part of the body which is immersed in the in that particular fluid. Okay, it means this is the volume which is equal to the volume of the body which is inside only. So if this part of the body is inside, so the volume represents the same volume of the body which is inside the fluid. So actual volume we have, and we have the volume which is the part of that thing. So it can be written as 0.00 and 0.7. So I hope that up to here each and everything is clear now. So how we will calculate the volume which is outside the water? So the volume which is inside the water, this one is the volume which is inside the water, this is the volume which is actual. So what is the outside volume? So we have that the outside volume, outside, that this will be outside. So outside will be equal to actual volume and minus the volume of the displaced water. So that is you can simply write down that this will be 0.1 to the power cube, that is 0.001. So it is 0.001, and minus this will be your 0.7 10 to the power minus 3. So it can be 0.7 into 10 to the power minus 3. Okay, so it can be also written as 1 into 10 to power minus 3 minus, it can be written as 0.7 into 10 to power minus 3. So it can be 1 minus 0.7 times 10 to power minus 3, and it can be written as 0.3 into 10 to power minus 3. So that will be in meter cube. So this is the volume which is outside of the water. So I hope that this question is now clear to all of you. So we will start your next topic in your next lecture. Okay, and up to then you have to revise your syllabus, revise each and every lecture what I have already explained to all of you. So thanks for watching me, thanks for listening me, and the best of luck to all of you.